Hi friends, today we are going to discuss about the cyclotron and its mathematical derivation. Cyclotron, it is a particle accelerator, that is a device which is used to accelerate microscopic charge particles. It's a primitive particle accelerator. In the recent times we are using many extremely complicated particle accelerators and all. Cyclotron is a primitive particle accelerator. In order to draw the diagram of cyclotron, we'll first consider two semicircular metallic discs. These are two semicircular metallic discs, that is two D-shaped structures, metallic. The metallic discs are connected with a high frequency oscillator, that is the metallic discs are connected with an AC power supply. It is called as a high frequency oscillator. Then this whole setup is kept in a powerful perpendicular magnetic field like this. It is kept in a magnetic field like this, that is magnetic field is inverse. Cyclotron is having an electric field and a magnetic field. The electric field is supplied by the high frequency oscillator and the magnetic field is applied in this fashion. The electric field and magnetic field both are mutually perpendicular. The electric field will be in these directions, the magnetic field will be inverse. Okay, then the charge particle that is to be accelerated is kept at the center of the disc, that is we'll have a platform over the metallic disc and we are placing the charge particle that is to be accelerated over here. Due to the combined effect of magnetic and electric field, the charge particle will spiral around like this and ultimately it is taken out of the cyclotron with the help of a deflecting plate. That is, I'm drawing a representation over here. This is a negative charge plate. It is called as deflecting plate. The function of that plate is to deflect the charge particle. That is, the charge particle is spiraling around like this, and if it is passing near the deflecting plate, due to the electrostatic attraction, the charge particle will move like this and it will fall over to a target. Okay, it will fall over to a target. This is the diagrammatic representation of cyclotron. That is, let me explain the working of cyclotron. The device is set up like this. The charge particle that is to be accelerated, let's say a positive charge particle, it is kept at the center of the cyclotron like this. The electric field will pull the charge particle in these two directions. As the polarity of the D's are changing, the electrostatic force will be in these two directions. The magnetic field is perpendicular to the motion of charge particle, therefore it will rotate the charge particle as we have learned in our previous sessions and all. Then due to the combined action, it will spiral around like this and ultimately it is deflected by a plate which is called as deflecting plate and it is hitting over to the target. When the charge particle is hitting the target, it will be in a very high velocity. Let's go for the mathematical simplification of this. In order to get the mathematical simplification of cyclotron, let me say the charge particle is revolving, that is it is having a centripetal force. The necessary centripetal force for charge particle is provided by the magnetic Lorentz force. The reason why the charged particle is revolving is due to the magnetic Lorentz force. Therefore, the necessary centripetal force is provided by magnetic Lorentz force. The expression for centripetal forces, yes, that is mv square by r. mv square by r is the expression for centripetal force, and the expression for magnetic Lorentz force, it is qvb sine theta. In this case, the magnetic field and the velocity is perpendicular. Therefore, theta is 90 degree. Therefore, sine 90 is 1. Therefore, I could write equation as mv square by r is equal to qvb. From this, one v and v square will get cancelled. We could write v is equal to qbr by m. And this is the expression for velocity attained by the charged particle. The charged particle will get a velocity of this much. V is the velocity of the charged particle coming out of the cyclotron. Q is the charge of that particle. B is the external magnetic field intensity. R is the radius of the D's of the cyclotron, and M is the mass of that charged particle. Then next we could find out the expression for kinetic energy. In order to find out the expression for kinetic energy, we know the general expression for kinetic energy is half mv square. Half mv square is the general expression. Therefore, substituting for v, we will get kinetic energy is equal to half m. V square means q square b square r square divided by m square. That means we are getting an equation for kinetic energy as q square b square r square divided by 2m. Since 1 m square and m will get cancelled. Therefore, now we have obtained the expression for kinetic energy also. Then next, let's find out the expression for frequency. In order to find out the expression for frequency, we could write angular velocity omega, it is equal to v by r. We have learned the expression for angular velocity as v by r. And we also know the expression for angular velocity is 2 pi nu, where nu is frequency. Therefore, combining these two equations, we could write v by r is equal to 2 pi nu, and nu is equal to v by 2 pi r. Then frequency is equal to, from this equation we know v is equal to qbr by m. Then what should be v by r? V by r is equal to qb by m. Therefore, instead of this v by r, if I am substituting qb by m, already there is 1 by 2 pi. Then instead of v by r, we could write qb by m. Then frequency is obtained as qb by 2 pi m. And this frequency, it is called as cyclotron frequency. It is cyclotron frequency. This is a peculiarity for this frequency. For the working of cyclotron, we have to supply a correct amount of frequency between the D's. That is, the high frequency oscillator should have a specific frequency. That specific frequency is nu, that is qb by 2 pi. If the frequency is above or below cyclotron frequency, the particle will be thrown out of the cyclotron. It won't be accelerating. Therefore, this is the cyclotron frequency. Cyclotron frequency is the frequency that is required for the working of a cyclotron.